Assalamu alaikum. In your fourth lecture, we're going to discuss a very important module in operating systems. The module that enables processes to communicate with each other. As we know, in modern operating systems, multiple processes coexist in the system, sharing system resources, sharing files, sharing CPU. For these processes to coexist, they need to communicate to avoid conflicts and inconsistencies. In this lecture, we will explore together the main concepts we need to understand in order to be able to design a successful, functional inter-process communication system. We can actually classify processes in the system into two main categories. Independent, that's to say, a process that is not affected and does not have any effect on any other process from the moment it starts to the moment it ends. And cooperating, these are processes who actually are affected and do have effect on other processes in the course of their existence. The question is, why do processes need to cooperate? They might need to share information. They might also need to work together in order to speed up computation. You can split the code between multiple processes so the execution will be faster. Modularity is another reason for processes to cooperate. As you might remember from software engineering, a modular design is the best way to modularity is the best way to design a code where it provides flexibility, maintainability, reliability, and each module can needs to communicate with other modules in order for the whole system to work. And for convenience, for example, if I am actually a user using a browser and I have a download that is going on and I need to browse whatever website I'm browsing while I'm listening to a streaming audio, it will be very frustrating if only one of these processes can exist while the other two cannot, because they're sharing the same resource, which is the browser. Having cooperating processes will be more convenient for the user. And user convenience was one of the main goals, if you remember. So, if there are processes that are coexisting and cooperating, they need to communicate. There are two main ways for processes to communicate, either through a shared memory or through a message passing system. A shared memory is a space in one process address space, that is the space in the memory allocated to process A, for example, and process A would allow process B to access this part of the memory in order to read or write or both. Operating system should provide the means to override the constraints of the operating system itself because operating system this carriages or actually prevents processes from entering the address space of other processes. Your inter-process communication system should give the means for a process to allow another process to share this space with it. So in this shared space, one can write and the other can read, and vice versa. The other way to do this is to have actually a mailbox where processes can send messages to each other. This mailbox does not belong to any process address space. It belongs to the system address space. And usually it's run by the system, sometimes it's run by one of the processes. One example that can explain the concept of inter-process communication better is considering two processes. One is a producer that produces data items, a writer, and the other is a consumer that consumes data items, that's a reader. If these two processes are sharing a memory, so one process will be writing to the memory addresses one by one. Memory is usually divided into bytes or words. So the process will be producing data byte by byte, process A, and process B will be consuming data, reading data one by one. The size of the shared address space between these two processes, which we call a buffer because it's a temporary storage space. It's a buffer. This buffer size can either be unlimited, so it's an unbounded buffer, or limited, so it's a bounded buffer. If the size of the buffer is unlimited, so the producer can produce as much item as it wishes, and the consumer can come and consume the items whenever it suits it. But if the buffer has limited size, that means the producer can only produce items until the buffer is full. Then it has to wait until the consumer, the reader, reads items from the buffer, freeing some space until it resumes producing data. And this creates need for synchronization. So the producer will not overwrite a memory space that was not read yet. And the consumer will not go and search for items of data while the producer did not produce yet.